Hello, this is Ben McGahee with McGahee Mathematics, and we're on the System of Equations video, lesson number 2, which is on substitution. Substitution is kind of a special technique we can use to solve a system of equations, two equations with two unknowns, and we could even do even bigger systems of equations, like three equations, three unknowns, and so forth. But for right now, we're just going to stick with the simple case with two equations, two unknowns, before we work even more complex examples. Substitution, you kind of think of it like as far as the sports analogy, when you have a basketball team and there's a certain player that's playing on the court and he's kind of tired, and the coach will substitute another player, right? A fresh player in place of him who is more ready to play. And there's also other examples with substitution, like say you're ordering something at a fast food drive-through, and you want to substitute maybe onion rings in place of French fries. Maybe you don't want the French fries with your value meal, but you just want onion rings instead. So we're going to see how substitution is put into practice, with an example here, and we'll see how it actually works and is related to what we just talked about with real life examples. So let's say I have two equations. We have x equals 4y minus 4. And then I have 2y plus x equals 8. So I have two equations, x equals 4y minus 4 and 2y plus x equals 8. And I want to solve for x and y, right? I want to figure out what the ordered pair is. Now we know in terms of graphing, that graphing method we learned in the first video of system equations, we can find out if there's a point, right, x, y, where these two lines meet, because these are basically two lines that can be graphed, and see if there's any point of intersection where they cross or meet. So substitution is more of an algebraic method where we don't have to draw a graph to find point of intersection, but we just solve for the variables x and y. So this is how it starts. So notice here that we have the variable x by itself in terms of y, right? X equals 4y minus 4. So what I can do is I can replace what x is, 4y minus 4, into this equation for x, because there's an x right there. So I'm doing a substitution. So in place of x, I'm going to put 4y minus 4. So that'll be 2y plus, so I'll just put this in parentheses. This is in place of x, 4y minus 4. That equals 8. So notice that we've reduced the equation, right? We had two variables, we had x and y, and now all we have left is just one variable, which is y. So this is a much easier equation to solve for now that we only have one variable. So what we can do now is we can remove the parentheses, so we'll just have just a 2y plus 4y minus 4 equals 8. And then we can combine like terms. We know 2y plus 4y is 6y minus 4 equals 8. And then we can add 4 to both sides. Get 6y by itself. Those 4's cancel. And then we're left with 6y equals 8 plus 4 is 12. And then our last step is divide by 6 to both sides. Those 6's cancel, and then we'll have y equals 12 divided by 6, that's 2. Y equals 2. Okay, so we have found the value of y, that's 2, and are we finished? Well, not quite, right? Because we need to find out what x is. We have to find out the value of x. So we know that x equals 4y minus 4. So now what we can do is replace y with the value of 2, because that's what we found out y to be, and plug it into this equation. So we're going to have x equals 4, my parentheses, times 2, that's y, minus 4. And so this equals 4 times 2 is 8 minus 4. And 8 minus 4 is 4. So we can see that x equals 4. So what is our ordered pair for this solution to system of equations? We have x is 4, comma, y is 2. 4, 2. So that would be our answer to this system of equations. 2 variables, 2 unknowns, 4, 2. Okay. So likewise before, when you solve a system of equations, it's always good practice to plug in the variables back in to check, just to make sure you have both equations check out. And I'm going to let you do that on your own, just to make sure that that they do check out, and they will. Just be careful when you plug in the right values for x and y and evaluate both equations. There is one more example we can work on for substitution, and let's take a look here. Let's say if we have negative 5a, so we're going to use different letters this time, plus 8b equals 20. Then we have a minus 3b equals 6. So this is our 2 equations, 2 unknowns. This time we're using the variables a and b. So when you're doing these kind of problems, you're not just going to be using only x and y, for every problem. You might have a and b, you might have m and n, or p and q. Just any two letters, can be okay. So we need to find out the order pair, right? Which would be a, comma, b. So we're treating it as alphabetical order. A comes before b in the alphabet, just like with x comes before y. So what we can do here is that we see that neither variable is isolated, right, or by itself, but we see that it can be easy to solve for the variable a in this case. So let's solve for a. So if we add 3b to both sides. The 3b's cancel. And we have a equals 6 plus 3b. 6 plus 3b. So remember, when you're adding something with a variable and then a constant, you can't combine those together because they're not like terms. So you can't just say 6 plus 3b is like 6 plus 3 is 9, 9b. That doesn't work. But if this had a b here, 6b plus 3b, that would be 9b. But so in this case, you can't combine these two terms together. They're not like terms. So now we know if a is 6 plus 3b, we can plug that into the other equation, right? The substitute in place of a. So we have negative 5 times 6 plus 3b plus 8b equals 20. And then we can distribute property. So negative 5 times 6 is negative 30. And negative 5 times 3b is minus 15b plus 8b equals 20. We can combine like terms. We have negative 15b and plus 8b. That would be negative 7b. So we'll have negative 30 minus 7b is 20. And then we can add 30 to both sides. Get the negative 7b by itself. So we'll have negative 7b equals 20 plus 30 is 50. And then we divide by negative 7. And then we'll get b that way. So b is going to be equal to negative 50 all over 7. There's an improper fraction, right? And can't be reduced anymore because 7 is a prime number and it doesn't go into 50. It's negative 50 over 7 is b. So now we need to solve for a, right? So in order to solve for a, we're going to plug in negative 50 over 7. We'll plug it into that b right there in this equation. A equals 6 plus 3b. And we can actually work that out up at top over here. So we'll have a equals 6 plus 3 times negative 50 over 7. So 3 times negative 50 is negative 150 over 1 times 7 is 7. So we'll have 6 minus 150 over 7. And this is kind of like over 1. 6 over 1, 6. And then we find a common denominator. We notice that'll be 7. So we just multiply 7 to 6 and 7 times 1. 7 to top and bottom. So that'll give us 42 over 7 minus 150 over 7. And so 42 minus 150, we know that's going to be negative. So we'll just do a subtraction here to the side. 150 minus 42. So we have to borrow. So it's 10. 10 minus 2 is 8. 4 minus 4 is 0. Bring down the 1. So that's going to be a negative 108 over 7. And so 7 does not go into 108 evenly. So that would be the answer for B. Or sorry, for A. A equals negative 108 over 7. Okay, so our final answer for this system of equations is A, negative 108 over 7, comma, B, negative 50 over 7. So that would be our answer to that system of equations. So I wanted to do an example there just with some fractions to show you, that sometimes the answers that you get for the variables are not always pretty numbers, right? Sometimes you're going to get some funky, strange looking fractions, just like with the 2 we just got in that last problem. And then other times you may get nice integers like 4 and 2, like in our previous problem that we did. So again, this has been McGahee with McGahee Mathematics. Thank you for watching this second video on system of equations. And in the third video, we're going to learn a new technique for solving system of equations called elimination. So we'll look forward to that video. Stay tuned.